Hi everyone, I am Charibeth Cheng. I am happy to be part of this year's IoTWoman. Sending greetings to everyone. Good morning, good afternoon, good evening, wherever you are in the world. My talk is entitled Lost in Translation, Why LLMs Fail at Cultural Context. This is a case study on the Filipino language. I am a professor at De La Salle University in Manila, where I lead a research group working on Philippine language technologies. Today, I want to share with you two of our projects that addresses concerns when powerful AI meets the messy, nuanced, deeply human reality of language, specifically our language, Filipino. So, how many of you have used an LLM in the past week? I'm sure almost all of you did, and I have to raise two hands because I always have two LLMs ready on my desktop. Now let's think back to our past experiences with an LLM. Has it ever said something that is a bit awkward, where it was technically correct, but it sounded awkward or insensitive to us? Sometimes it may even be offensive because it completely did not understand or it misunderstood us for our culture or our context. That feeling, that gap between what the model said and what it should have understood, that is exactly what this talk is about. They say, and I would agree, that we live in the golden age of LLMs. Models can write code, they can summarize legal documents, they can even pass medical exams. And yet, give one of these models a sarcastic tweet in Filipino, and it will most likely not detect the sarcasm that is expressed in it. And this is what we call the nuance gap, the failure to distinguish literal meaning from cultural context. The model reads the words, but it misses the world behind those words. And this is not a quirky edge case. The Philippines has over 112 million people. Most of them are deeply engaged in social media and the internet, where AI tools are already being deployed for content moderation, for content creation, for mental health support and education. These are real systems making real decisions for real people. And this may also be the case where you are at right now. When these models are deployed for real users, especially vulnerable ones, the consequences become deeply personal. Think about who these systems are actually being built for in countries like the Philippines. Children use AI tutors because access to good teachers is unequal. It depends on where they are and who they are. Teenagers in crisis reaching for a mental health chatbot because human support is inaccessible or unaffordable. Low literacy users use AI because AI cannot help can are supposedly there to help them navigate through misinformation. These are not edge cases. These are the primary use cases for AI in the Philippines and many other places where access to resources is not equal. And I agree, I would be among the first to propose AI in these use cases because AI is a powerful tool to supplement the lack or the unequal resources in education, in healthcare, and in knowledge access. But when the AI gets it wrong, for these cases, the consequences become deeply personal, if not catastrophic. So what may go wrong? A child can ask an AI tutor about Philippine history, and the model, trained overwhelmingly on Western data, may give an answer that is not just incomplete, but may culturally be distorted. And the child has no baseline to challenge it. We trust the machine. Even I trust the machine. And that trust is the vulnerability. Second case, a teenager in distress opens a mental health chatbot because that is what was available to them. A model with Western trained safety filters may miss local crisis signals entirely, or it may flag culturally normal expressions of grief as alarming, and it responds in ways that may feel cold or irrelevant. And the teenager may stop trusting the tool. Or worse, the tool escalates inappropriately. Third case, a low literacy user is trying to verify a news story. The fact-checking AI, trained without Filipino cultural context, may fail to catch sarcastic disinformation prevalent in Philippine social media. A study done last year found out that 65% of Filipinos struggle to spot misinformation or disinformation. And an AI that makes this state worse is not a tool, it is a liability. When an AI makes a cultural mistake, the consequences go beyond a wrong answer. That mistake ripples into trust. A model that does not understand the culture doesn't just give a wrong answer. It gives a wrong answer to someone who cannot tell that it is wrong. Let me repeat that. A model that does not understand the culture doesn't just give a wrong answer. It gives a wrong answer to someone who cannot tell that it is wrong. So why should IoT developers care? Why should any developer care? This sounds like a policy problem or a linguistics problem. So why should I care? If you have ever trained a model or built a RAG pipeline or evaluated outputs of AI or designed a data set, you have already made decisions that determine whether an AI system helps or harms its users. Decisions that answer to questions like, what data and language was the base model trained on? Which documents should be in the database of the RAG system? What counts as a correct or a wrong answer? And who are the creators of the dataset? And whose cultural experience do these datasets represent? Each one of those decisions is a cultural assumption in disguise. If one does not examine it, the default choice is made, and that choice is we are using someone else's culture and applying it to our own users. For me, the nuance gap is not just a single problem. It is four distinct technical challenges that compound each other. And I call them the four architectures of ambiguity. First is the linguistic inversion problem. Sarcasm, irony, and other figures of speech, they flip literal meaning. The surface form says one thing, but the cultural meaning says the opposite. We've tested and discovered that the most accessible LLMs fail to consistently detect sarcasm and irony in Filipino. I think this is also true in most non-English languages. Second is the context vacuum. When a model processes text stripped of its social and historical context, it fills that vacuum with whatever dominates its training data, which is mostly English, mostly Western, mostly from a very specific demographic. The model's understanding is a projection of a foreign world view being pushed on a local reality. Third is the data desert. For Filipino and most Southeast Asian languages, annotated, high-quality datasets are scarce. Without data, we cannot train and evaluate properly. And without proper evaluation, we cannot deploy safely. And fourth is the limited safety filters. Off-the-shelf safety tools encode Western assumptions. We see they flag Filipino expressions that are culturally normal as toxic because when these words are translated, they are actually obscene. They are very strict, these models, they are very strict on profanity and cuss words. However, they miss locally specific signals of real harm, such as gender-based harm, class bias, regional bias, mental health invalidation, and these are just some of what we have discovered. Deploying these models uncritically is not neutral. It is harmful by default. These four challenges or architectures of ambiguity is what my lab is working to address. And let me show you two examples. Phil sarcasm or Filipino sarcasm addresses architectures 1 and 3, which are linguistic inversion and data desert. Consider this tweet. Ang galing talaga ng gobyerno natin. 5 taon na, wala pa rin. In English, our government is really great. 5 years in and still nothing. An AI may just see the surface form and think that this is actually a positive remark because of the words great, right? Any reader knows immediately that this is bitter sarcasm. The speaker is frustrated. The surface form says one thing, the cultural meaning says the opposite. And no English-trained model can consistently bridge that gap because the gap is not linguistic, it is cultural. Our response is Phil sarcasm. We target a benchmark of 10,000 Filipino political tweets, manually annotated for sarcasm, with at least 3 annotators per tweet, spanning years of major political events. Phil sarcasm can be used to teach an LLM what Filipino sarcasm is. It may also be used to assess an LLM's behavior when exposed to Filipino sarcastic remarks. The key design issue in Phil sarcasm is what we call cultural scaffolding. Cultural scaffolding. A bare message is almost uninterpretable without context. So each entry in our benchmark is going to be enriched with the political or social background a Filipino reader would already carry, such as the event being referenced, why people are angry, and what these phrases actually mean in this moment. This means we are not just asking, can a model classify an input? We are actually asking, can a model correctly classify the input when given the same cultural context a human annotator would have? That will be a more rigorous and a more honest evaluation. And when the model still fails with that scaffolding in place, then we know precisely where the gap is. The second example is ligtas, or safe in Filipino. In English, ligtas, safe, which addresses architectures 2 and 4, the context vacuum and safety filters. Most LLMs have built-in safety systems already, including those for content moderation, toxicity detection, and harmful output prevention. These safety systems are presented as universal when actually they are not. Safety filters are what I call weird, and this term, weird, is not from me. It is a term coined in a 2010 behavioral science paper. Weird stands for Western, educated, industrialized, rich, and demographic. Weird, W-E-I-R-D. Just like how the authors in that 2010 paper pointed out that behavioral science research is weird, I also find off-the-shelf safety filters as weird. Here's what weird safety looks like. A model flags a commonly used Filipino expression of frustration as toxic because the nearest English equivalent is an obscenity. But for us, it is a usual term of frustration. Yes, it is offensive, but normally for most people, we just accept it as a term of frustration. These expressions could be the Filipino cause expressions that are overly descriptive. But that same model that would block or would consider those expressions are as toxic, that same model usually completely misses implicit expressions of a different kind of bias, harassment, and toxicity. Deploying these systems uncritically in non-Western contexts is not a neutral action. It is harmful by default. Ligtas, which means again safe, is our way to address weird. Ligtas is also a manually curated benchmark covering 8 harm categories, namely toxicity, hate speech, emotional harm, subjective topics, misinformation, personal attacks, cultural insensitivity, and safety risks, all defined through a Filipino cultural lens. Like Phil sarcasm, we will use human annotators to establish ground truth, not automated metrics alone, although we would still be using automated metrics. The question we ask is not, does this respond avoid harm according to a Western rubric? Rather, we ask, does this respond or does this response avoid harm in ways that actually matter to Filipino users? We are building both Phil sarcasm and ligtas because we cannot deploy safety what we have not evaluated honestly. And we cannot evaluate honestly without benchmarks built for the context we are deploying to. And that's why we are first building these two benchmark datasets. So what does this mean for us? What does this mean for IoT developers or for developers in general? First, please question your benchmarks. We have to question the benchmarks that we use. When we evaluate a model, we ask, who built this benchmark? Whose language? Whose cultural norms? Whose definition of harm? If the answer is always English speakers in the West, that is a signal that we should not ignore. Second, let's invest in localized evaluation. If we are building AI tools for diverse populations, then we should build diverse evaluation or test sets. A small, high-quality, culturally grounded dataset is worth more than a large generic one. Third, when we benchmark, let's be honest about what we are actually testing. A model evaluated on decontextualized data is not being tested on cultural understanding. It is only being tested on pattern matching. Let us design our evaluation so that the task reflects the real conditions our users will face when they use our models. And then fourth is to collaborate. The problems we face in Philippine NLP is not unique to us. Our neighbors, Indonesia, Vietnamese, Thai, and the Tamil language, every low resource language community is fighting the same battles. So let's share benchmarks, let's share tools, let's share findings. This work does not scale unless we build it together. The Philippines is a fascinating test case. We have around 170 and more, 170 plus languages with a colonial history layered into our vocabulary. We have a digital native population with active political discourse in social media. But the Philippines is not an exception. It is a preview. The Philippines is a proxy. We share the same cultural challenges with our regional neighbors and maybe even outside of our region. The work we are doing in Manila is proof that culturally grounded AI is possible and we have to try to achieve it. what? That we can move beyond grammatical correctness and towards an AI that understands the unspoken and also the unseen. LLMs are extraordinary tools, but they are not culturally neutral. They never were. So, building LLMs as if they were culturally normal or not culturally neutral is not enough. There is a need to do the harder and more important work of making LLMs truly inclusive. The dev community is has always been global. Our tools, they reach everywhere. So let's make sure that the AI we build, the models we evaluate, the benchmarks we create, the safety systems we deploy, reaches everyone. Maraming salamat po. Thank you very much. And if you are working on low resource language NLP, I would truly love to talk with you. Thank you.